Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. So my dear student, today's topic for the lecture is the alpha scattering experiment, that is the discovery of nucleus. My dear student, this experiment was performed by Rutherford and his co-workers Geiger and Masder in 1911. So let me write some introduction. First of all, I'm writing this experiment was performed by Rutherford and his co-workers Geiger and Marsden in the year 1911. So let us discuss what they have done in this experiment. In this experiment, a beam of alpha particle was directed towards the thin gold foil of thickness 0.0004 centimeter. I'm writing in this experiment a beam of alpha particle was directed towards thin gold foil of thickness 0.0004 centimeter. After passing through the foil, after passing through the foil, that beam of alpha particle was made to strike the fluorescent zinc sulfide screen. Now, when the alpha particle crosses the gold foil, then it is made to strike the fluorescent screen, that is the zinc sulfide screen. So what will happen when alpha particle will strike the zinc sulfide screen? So I'm writing when alpha particle strikes zinc sulfide screen, a flash of light is obtained. A flash of light is obtained, that is scintillation. That is scintillation on screen. Now, Rutherford have studied the positions of scintillations on the screen, and after studying that he had made certain observations. So before starting the experiment, let us discuss firstly what is alpha particle. So I'm writing in a questionnaire form. I'm writing what is alpha particle. So its answer is alpha particle is actually helium dipositive ion. That means you are having an element helium. Its atomic number is 2. Its mass number is 4. When the helium loses 2 electrons, then helium becomes dipositive, but mass number remains the same, that is 4. So this dipositive helium ion is my alpha particle. So it is actually the only nucleus of helium. Now let's talk about the mass of alpha particle. I'm writing mass of alpha particle. It comes out to be 4 AMU, that is 4 into 1.66 into 10 raised to the power minus 27 kilograms. That's the mass of alpha particle. And let's talk about the charge of the alpha particle. I'm writing charge of alpha particle. Its dipositive helium ion means its charge is plus 2e. It comes out to be plus 2 into 1.6 into 10 raised to the power minus 19 coulombs. So that's my charge of alpha particle. Now the next question arises. From where do we get alpha particle? So now let's talk about it. Firstly, helium. Simple helium atom. The 4 mass number, the 2 atomic number. It's a noble gas atom with stable electronic configuration. So I'm writing, so it will be very difficult. It will be very difficult to convert helium atom to helium dipositive ion, because helium atom is a noble gas atom with a stable electronic configuration. It will have a very high ionization energy, which we will discuss in the next lectures. So it is very difficult to convert an helium atom to helium dipositive ion. So from where do we get the alpha particle then? We will obtain it by radioactive decay of some radioactive element. So from where I will get the alpha particle? So alpha particle will be obtained from radioactive decay of some radioactive element. And that element, radioactive element, I am taking its example to be polonium. The Rutherford have used the polonium atom, the radioactive polonium atom, to obtain the alpha particles. So now dears, let us discuss the diagram above the Rutherford alpha ray scattering experiment. So I'm drawing the diagram for alpha ray scattering experiment. Alpha ray scattering experiment. First of all, I'm making an assembly first. I have made this assembly, and Rutherford has taken polonium over here, the shaded region. So that is a polonium. The shaded region is polonium. After that, he has taken these lead plates. After that, a very thin gold foil of thickness, I'm writing gold foil of thickness only 0.0004 centimeter, and behind the gold foil he has taken the zinc sulfide screen. Let me draw the zinc sulfide screen. So that's a zinc sulfide screen behind the gold foil. I'm writing zinc sulfide screen. This screen is fluorescent in nature. That is, it produces a flash of lights when the alpha particle strikes them. So now what will happen exactly now? The polonium will emit the alpha particle. Polonium will emit the alpha particle, and that beam of alpha particle will be guided by lead plates to strike the thin gold foil. First of all, my dear students, this was the lead plates. Let me do it again for you. What will happen? That polonium will emit the alpha particle, and that beam of alpha particle will be guided by lead plates towards the thin gold foil. So that will be the direction of beam of alpha particle. Now, when the alpha particle strikes the gold foil, after crossing the gold foil, the alpha particles will strike the zinc sulfide screen over here, and they will produce scintillations, the flashes of light over here. After that, Rutherford observed flashes of light in this region, even also in this region, even also in this region. So what does it signify? That few alpha particles, after striking the gold foil, got deflected from their original path and have striken the gold foil over here, or over here. So the position of scintillations were the key observations of Rutherford from where he has given the certain set of rules and his results of the experiments by studying the positions of scintillations on the zinc sulfide screen. So now let us talk about the observations made by Rutherford. So I'm writing results of the experiment given by Rutherford on the basis of observations on the basis of observations of positions of scintillations on zinc sulfide screen. So now let's talk about the very first observation and the result. Most of the alpha particles went straight through the gold foil without any deflection, as most of the scintillations was just behind the gold foil. So I'm writing most of the alpha particles, more than 90%, most of the alpha particles went straight through gold foil without any deflection, without any deflection, as maximum scintillations, as maximum scintillations was just behind the gold foil. Now, which scintillations? Please look at a diagram, as most of the scintillations was just behind the gold foil on the zinc sulfide screen. Please do have a look. The scintillations was just behind the gold foil on screen. So what does it proves? It proves that gold atoms in gold foil have empty spaces in them. It proves that the gold atoms in the gold foil have empty spaces in them. I will clear this thing when I will draw the diagram of zoomed in atom of the gold foil. So it proves that gold atoms in a gold foil have empty spaces in them. So now let's talk about the second observation. Before starting the second observation, let's discuss about first of all the angle of deflection. What do we understand by the angle of deflection? Please have a look at this diagram. This is the beam of alpha particle going on its path. At certain point, this beam changes its path. Now, what was the original path? This was the original path. The alpha particle have changed its direction. So, the angle, the angle by which the alpha particle have changed its path is the angle Q. That's called angle of deflection. So now let's talk about the second observation in detail. I'm writing very few alpha particles deflected at a very significant angle, deflected at a very significant angle. Let me come back to the diagram. Which alpha particles? According to the observations of scintillation on zinc sulfide screen, please have a look at the diagram. These observations, these scintillations have made Rutherford to think that some alpha particles have deviated or deflected from their original path. So I'm writing over here, very few alpha particles deflected at a very significant angle. Significant angle when they strike the gold foil. When they strike gold foil. Very few alpha particles deflected at a very significant angle when they have striken, when they strike the gold foil, when they strike the foil. So, what does this infers? It proves that there were repulsive forces. There were repulsive forces between alpha particles and positive particles, that is protons, present in gold atoms. The gold atoms obviously present in the gold foil. So, it proves that there were repulsive force between the alpha particles and positive particles, that is protons, present in the gold foil. What charge the alpha particle bears? It's a helium dipositive ion. So obviously alpha particle is also positive and protons are also positive, and like charges always repel each other. So this was the second observation. Now let's talk about the third observation. The third observation is that very few alpha particles bounced back with an angle of deflection, with an angle of deflection of 180 degree, which was very surprising. So from this observation, Rutherford inferred that, I'm writing, this observation also proves that, so it proves that all the protons present in an atom, present in an gold atom, are concentrated at heavy center, are concentrated at heavy center in an atom, and that heavy center is termed as nucleus. So that was the discovery of nucleus in this alpha ray scattering experiment. So my dear students, I am now going to draw the zoomed in diagram of the gold foil and the alpha particles. Please do have a look. Let us take, this is an outer orbit of an atom, and that's its nucleus. That's my nucleus with positive charge, and electrons just revolve around the nucleus. So that's a complete zoomed in structure of atom. Now I'm talking about the alpha particles now. So now the first observation was that most of the alpha particle went straight without any deflection, which confirms that most of the space within an atom is empty spaces. Now let's have a look. This is the alpha particle coming, and it went straight without any deflection. The first observation. This is also the first observation. The alpha particle went straight without any deflection. Again alpha particle went straight without any deflection. This alpha particle also went straight without any deflection, and this alpha particle also went straight without any deflection. So now let's talk about the second observation. The second observation was that few alpha particles deflected at a very significant angle. So let's talk about it. This is my alpha particle coming now. When it approaches near the nucleus, it gets deflected in this path. That's the another alpha particle coming. When it approaches the nucleus, it gets deflected in this direction. So that was my second observation. Now let's talk about the third observation. Very few alpha particles bounced back with an angle of deflection of 180 degree. So now let's talk about this thing. The very most important observation. This is the alpha particle coming, and it's coming directly towards the nucleus. When it approaches near the nucleus, this alpha particle deflects back with an angle of deflection of 180 degree. So that proves the presence of nucleus. That is, all the positively charged particles are concentrated at heavy center called nucleus. That means all the positive particles, that is protons, are concentrated at heavy center called nucleus. So this was the alpha particle that confirmed the presence of nucleus. So now let's talk about the factors on which number of alpha particles that will get deflected will depend. So I'm writing the number of alpha particles that gets deflected by a significant angle will depend on following factors. The very first factor is the thickness of gold foil. The thickness of gold foil. How much thickness of gold foil Rutherford has taken in this experiment? It's 0.004 centimeter. It is very thin. It is very very thin. If we increase the thickness of gold foil, then there will be more layers of atoms of gold in the gold foil. Then there will be, obviously, if there are more atoms, then there will be more nucleus. The more nucleus, the more deflections will be there. So number of alpha particle getting deflected will be more if the thickness of gold foil is increased. So now let's talk about the second point. It is also dependent on atomic number square, that is Z square of the metal whose foil we are taking. Just think, if we are having more atomic number, that means there will be more protons in the nucleus. The very strong repulsive forces will be there then, due to which the number of alpha particles getting deflected will be increased. So I'm writing more atomic number, that stands for more protons in the nucleus, which further proves that more or strong repulsive forces, you can use the word strong, then there will be more strong repulsive forces, more strong repulsive forces between nucleus and alpha particle. Hence, the number of alpha particles getting deflected will be increased. Now let's talk about the third factor on which it depends, that is, it is inversely proportional to the fourth power of velocity of alpha particle. What does it signify? If the velocity of alpha particle is more, it will cross the gold foil without any deflection. If the velocity of alpha particle is less, then once it gets closer to the nucleus, it will get deflected very easily because velocity of alpha particle is less. If alpha particle is coming very fast, it will pass through the gold foil or it will pass through an atom without any deflection. So the number of alpha particle getting deflected will be inversely proportional to the velocity of the alpha particle. So now let's talk about one important term, the number of alpha particles deflected by an angle Q. Hopefully you remember what's the angle Q. Here it is, the angle Q. So the number of alpha particles deflected by an angle Q will be inverse of fourth power of sine into angle of deflection divided by 2. So that was just a little relation that I have written down. So I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class, then he or she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.